Okay, so this video is going to be about identifying transformations, and all of my transformations are going to come from our parent functions. So the first thing that I have to identify before I can figure out what my transformations are is my parent function. So this is going to be my most important step, is saying, okay, what's the parent function? So given the equation f of x is equal to x cubed minus 4, I have to say, okay, well, what's my parent function? And my parent function is going to be f of x is equal to x cubed. And if we remember the different transformations, there's different parts for my parent function. My parent function is f of x is equal to a times b x minus h cubed plus k. And each part means something different. A is my vertical change. Let's write that down. A is going to affect my vertical change, vertical stretch or compression. B represents my horizontal stretch or compression. H represents my horizontal shift. And K represents my vertical shift. So I have to figure out what part exists in the equation that I'm translating and that I'm moving. So I have the equation x cubed minus 4. So I have this minus 4, and I have to figure out if that represents the A, B, H, or K. So because I don't have any parentheses, I'm pretty sure I don't have a B or an H. So A would be the number in front, and I don't have a number in front, or technically that number is 1. So negative 4 is going to be my K, and that's my vertical shift. So negative means that I'm going down, so this graph translates down 4 units. So the next equation that I'm going to look at is going to be f of x is equal to 2 times the square root of negative x minus 1. And I'm still going to look for all of my parts. I'm still going to look for the part that represents the horizontal shift, the vertical shift, the horizontal stretch or compression, or the vertical stretch and compression. And I'm going to look for my parent function. So this is a square root function. So my parent function would be a times the square root of b x minus h plus k. So my my vertical stretch and compression is still going to be my A. My horizontal stretch and compression is still going to be represented by my B. My horizontal shift is going to be my H. And my vertical shift is still going to be the K. So my letters, the position of them don't change. My generic letters, A, B, H, and K, don't change. Neither do their meanings. So I'm still going to look at what all this means, or what all the parts mean. So I have a vertical stretch here because this is a 2. This is a vertical stretch. So I have a vertical stretch. By a factor of 2. So A and B, if they are negative, if A is negative, it can also have a reflection over the x-axis. If B is negative, I can have a reflection over the y-axis. And in this case, I have a negative B right here. So I am having a reflection over the y-axis. Separate those two real quick. I have a -1 right here, and a -1 is in the place of my h, so that is a horizontal shift. And if you remember, my horizontal shift is always, it's kind of like my hypocrite. It lies, it goes in the opposite direction. So my horizontal shift is going to go to the right 1. So I have a horizontal shift that takes me to the right 1 unit. So this transformation has 3 parts. I have a vertical stretch by a factor of 2, a reflection over the y-axis, and a translation of right 1 unit. Okay, so the equation f of x is equal to -1/4 x squared plus 6. The parent graph for this is a quadratic, so the generic form for it would be f of x is equal to a times bx minus h squared plus k. I'm going to go ahead and identify all of my parts. My horizontal shift is my h, my vertical shift is my k, my horizontal stretch is my b, and my vertical stretch is my a. So a, b, h, and k. And I need my parts. Remember, if A is negative, that's also going to be my reflection over the x-axis. If B is negative, that is my reflection over the y-axis. Okay, so let's see what parts I have here. I have a negative outside my parentheses in place of my A, so this particular graph is definitely going to be reflected over the x-axis. This has a number inside the parentheses in front of the x. This is going to be my horizontal stretch or compression. In this case, it is a horizontal stretch by a factor of 1/4. I have a number outside my parentheses. My number outside of my parentheses represents my vertical shift. My vertical shift tells me that this graph is translating up 6 units. Okay, so this is the last example I'm going to do for this video. This example is f of x is equal to the absolute value of -1/3 parentheses x minus 4 close parentheses and then plus 7. So just like before, I'm going to go ahead and set up the generic form. The generic form is f of x is equal to a absolute value of b x minus h close the absolute value plus k. And I'm going to set up all of its parts. So the first thing I'm going to have is I'm going to say A, and I don't have an A in this case, but A is going to be my vertical stretch or compression. B is the horizontal stretch or compression. H is the horizontal shift, and K is the vertical shift. Again, if you notice, the values or the description of A, B, H, and K don't change. Again, if A is negative, then we will reflect over the x-axis. If B is negative, we reflect over the y-axis. So looking at this equation here, I do have a negative. It's inside of my absolute value, so that's going to represent my B. I do have a 1/3. It's also inside my absolute value, so that's also going to affect the B. The H is -4. Remember, that's kind of like my hypocrite, so it's going to do the opposite. And then the 7 is going to take care of the K. So let's get to it. So H gives me a reflection over the y-axis, gives me a horizontal stretch by a factor of 1/3. My H is my horizontal shift. Remember, that's my hypocrite. By 4, so it's to the right 4. Even though that's a negative, the hypocrite tells me that I'm going to change its sign, so a -4 becomes a positive, which is why it goes to the right 4. And then my last one is a translation up. Seven units. So that takes care of my identifying transformations.